presenting my research project to build a restaurant recommendation engine. So, what is the purpose of a recommendation engine? Well, in today's digital world, we're presented with huge volumes of information every day. And while offering a wider range of options has been shown to have a positive impact on drawing new customers, too much information can lead to confusion and decision dilemmas. And this is where recommendation engines come in. They help solve the information overload problem by effectively searching through all items and assigning rank to each recommendation based on its relevance. And looking from a business perspective, they can also provide a platform to bridge the gap between consumers and providers, as business owners can use this application as a way to increase the visibility. So this is a quick schema of the data that I used to build the recommendation engine. As you can see, it's a very small data set of only 138 users and 130 restaurants. The ratings range from 0 to 2. We first use collaborative filtering to select items based on interactions collected from similar users. Next, we use non-negative matrix factorization to decompose the ratings matrix. Finally, we used Skyline queries to rank the recommendations. Here's an example of a Skyline query run on a set of recommendations for the cheapest hotels that are close to the beach. Going further into the first step, collaborative filtering, it is based on the idea that users who have similar tastes like to go to the same restaurants. The user base is split into two different buckets. We have the returning users, and then we have the new users with no rating histories. In a case of a returning user who's already rated a few restaurants, we have an idea of what kinds of restaurants they like and what are the ones that they don't like. We can use k-means clustering to group the restaurants into cluster. The goal is to find restaurants with similar features to the ones already rated highly by the user. The user-to-restaurant relationship is then put into a matrix R. In a case of a new user, this is the registration information that we have on them. Given these attributes, we can use KNN to find other users that share similar characteristics to this new user. And similarly, we put the user-to-restaurant relationship into this matrix R. Next, we use non-negative matrix factorization to decompose that matrix R. After this step, we end up with W and H, and taking the dot product of these matrices gives us another matrix, which is the approximation of matrix R, with the NAs replaced with predictions that we need. Then we use Skyline queries to order the recommendations based on their relevance. There are two important criteria that consumers often consider when choosing a restaurant: distance and rating. Skyline queries help in the evaluation of both criteria to determine where each recommendation should be placed relative to its alternatives. Skyline queries return restaurants that have a good combination of both criteria that the user is interested in. This is the Skyline for a random user. We're looking for the line that's close to the axes that represents the maximization of the ratings and minimization of the distances. To test the model's performance, we randomly chose a returning user, and we calculated the mean squared error to be 0.8, and the mean squared error for this new user is 0.25. The overall mean average recall at K for returning users is 0.2288. This indicates that the restaurants rated highly by the user are in the first 20 recommendations only 22.8% of the time, and 21.83% of the time for new users. And again, this is a very small data set consisting of only 130 restaurants. The recall and precision scores could have been improved if we had more data to work with. Also, the predictions are a lot higher than the ratings. This is because the training data is very skewed, consisting of mostly 2s. And with a larger data set and more variance in the ratings, we could have produced better results. The methodology proposed in this project can also be transferred in other applications, such as finding nearby COVID testing centers, in dating apps, trying to match users using similarity and distance, finding doctors' offices, also using ratings of the doctors and distances. Skyline queries can also be used in the optimization of multi-dimensional problems to return an optimal set of recommendations that represent a good combination of all dimensions. And that concludes my presentation. Thank you for listening.